Okay, so the recording is now on, and I will share the screen soon. But before the screen, let me just recap what we have been discussing and what we are going to discuss today. We have been talking about cellular mobile communication, and today we are going to talk about the cellular mobile generations. Like, I will be mostly talking about the 1G and 2G today, and on Friday we'll be talking about 3G and 4G. So you will have an idea of how the things progressed over generations. And you might ask that why we are going to understand the 1G or 2G. Well, although the 1G does not exist or was not implemented in India, but 2G was heavily implemented, and that was a big boost. So you need to understand the rapid changes in economy, telecom sector, and the whole market. And some technologies even exist till today. So, to the best of my prediction, is that the older generations are not going to be away very soon. There will be something like coexistence in, at least in the developing countries like in India. And we will try to supplement this evolution path with some personal experience and stories which we witnessed as we were part of this development. And maybe you can also relate with your experience, like how we progressed from different generations to other generations. So let me start the discussion on 1G. This will open a PDF. Okay, so I guess you can see now on your screen there is a PDF thing which is handwritten notes. So I will just use it to give you the pointers. The most of the things I will explain. So let us try to again understand the history of cellular mobile generations. Like they were primarily the reason because of the public safety departments. The public safety departments required some mobile communication equipment that is to be fitted primarily to their cars, and also it's like a police car which needs to be in constant connection with the police station, and then fire vehicles, fire extinguishing vehicles, and so on. And again, some people wanted also their car phones. So that was something like the first generation phones which were being developed. Now you have to understand that just like landline phone, the first generation phones are all analog in nature, and they were have something like circuit switched. I hope I discussed the circuit switched idea in the class, like what is circuit switching and what is packet switching. Anyway, so the first generation phones were being developed in around 1980s or so, and there were something like discrete developments in different countries, and they were not at all compatible to each other. So in US they had a standard called advanced mobile phone system, or AMPS, and that might sound very ridiculous, like advanced, but anyway, that's what they called. And obviously at that time they didn't think it about what 1G. When 2G came, then it became 1G naturally. Now, it was in US which had AMPS, and then UK there was TACS, which was Total Access Communication System, and in Scandinavia means Norway, Sweden, Finland, Denmark. These countries were always a pioneer in cellular mobile communication. So if you ask that in the networking domain or in communication network, which are the leading countries, we have several answers. Like if you consider cellular mobile networks, the always one of the big leaders were these Scandinavian countries. Because if you name some companies, the early companies like Nokia, it is from Finland, and then Ericsson, it is from Sweden. So these big companies all come from these areas. Also, another country was very progressive about these things, which is Japan, which I will talk in 2G in detail. So these are countries are mostly leading countries in the cellular mobile domain. On the other hand, if you consider telephone network or telephone switching or something, then South Korea is one of the big leaders behind this. So if you ask that which country on an average enjoys the highest internet speed per user, I guess it is still South Korea. And the number of percentage of homes that are connected to broadband is quite astounding in South Korea. For example, in Seoul, it's probably from 10-15 years back, they have stopped using cable television. They have been watching it through internet for long. So that's the kind of speed, and they have something like 5 years telecom network policy, just like we have 5-year plans in India. So they are that much advanced. Anyway, coming back to the first generation discussion, well, we had something like NMT in Scandinavia, that was Nordic mobile telephone, and there are also Germany and other places where this kind of things were taken care of. Now, what were the primarily things which we should focus on 1G, or what lessons or what big achievements we had in 1G, which are still carried? Well, for the first time, it was felt that we need some kind of licensing. You might have heard about 2G scams and all these things, and you probably know about spectrum auctions, like the TRAI, Telecom Regulatory Authority of India, sells the spectrum for a price to the telecom operators like Reliance or Airtel or something. Now, that drive started from 1G, because in 1G, they first felt that people want this and people need to protect their frequency band so that other people cannot interfere. So probably you need a regulatory body or government intervention is necessary. So that was a big learning experience in 1G. And once the 1G was coming up, soon the regulatory authorities were being formed. Like FCC has got up their separate wing. In many other countries, these regulatory bodies were coming up. Like in Europe, it was like ETSI, European Telecommunication Standard Institute. In Korea, it was ETRI, and so on. So that was lesson number 1. Lesson number 2 was that the cellular idea that I have been describing in the last 2 classes, like that is the geographical area that you cover is not good enough to be covered by one particular tower, because the amount of spectrum that is available is not enough to accommodate the number of users which demand the service. So that's why it is good to divide the geographical coverage area into smaller areas, which are called cells. And in these cells, you need to use the frequencies again and again. So the frequency reuse or the cellular structure was also standardized during this 1G. So this 1G was something like that came. Then there was also something like the integrated backhaul network. Now, backhaul means how the towers are going to get the signals from. So I hope you remember that there are 3 components I have described in the class. There is mobile station, there is base station, and there is mobile switching center. So these kind of connection, that the signal will come from mobile switching center to the base station to the cell phones, this kind of architecture or this kind of design was also standardized in 1G. So these things still continue today. Like these are the lessons learned from 1G, and these lessons are still being carried out, and they are still being used in today's work. Okay, now why we have graduated from 1G to 2G? Well, there are these 3 things which probably fueled the gradual movement from 1G to 2G. Well, sorry for the interruption. So what I was discussing was that why we have graduated from 1G to 2G. And while there are 3 reasons mainly. The first thing was incompatible frequency bands. Now, what do we mean by that? Well, every country were developing their own system, and they had their own frequencies. Like the amps used the 800 megahertz band, tax used 900 megahertz, NMT uses 450 megahertz. So they were incompatible with each other. That means no such facility of roaming was thought of. Like at that time, nobody thought that you can probably take a mobile phone to another country and you can still be able to make a call. So, but the demand was soon rising, and the demands were pretty high in developed countries which are very small in size, like in Europe, where inter-country movements were very common. Then the second limitation of 1G was limited capacity. Well, the amount of frequency bands that were allocated were of limited capacity. Well, it is not the technological kind of limitation. I should say it is a policy kind of or regulation kind of limitation, but it was giving immense pressure on the regulatory bodies to allocate more spectrums, come up with more spectrums and so on. Now, you might obviously ask that who is holding the regulatory authorities to holding back the regulatory authorities to allocate more spectrum? The answer is the mother nature has given the whole spectrum to us, and it is up to us how we use them. But already other services have been using the large spectrum, and that had been allocated to them. For example, defense sector has been gobbling up a large portion of the frequency spectrum, and they are not ready to let it off, giving reasons of national security and so on. And then there are satellite services which require also a large part of the spectrum. So there were only very few spectrum holes that were available, which or the spectrum gaps which are available, which can be allocated to cellular mobile. And people were demanding that probably you should take the spectrum from the military agencies and from the satellite sectors and give it to them. And that has been a debate for almost last 25 years or so, and it is still very, very hot. Like even in 5G, the spectrum allocations, there had been a lot of debate. Like for example, there were some TV signals which were not being used and that were still allocated to the TV transmitters. So that has been taken up by 5G and so on. So that's another limited capacity. Then the third one was device limitation. Well, when I was talking about 1G, I'm talking about 1980s. Well, smartphone is not nowhere in near vicinity at that time. And even the phones that were made was something like very bulky cordless kind of phones, which were very heavy, which never fitted into a pocket, and they had a low battery life. So there was limitations from the battery side, there are limitations from the mechanical engineering side, and they are still very, very costly. So you have to think that when we consider the cellular mobile generation upgrade, it's not about only the achievement of electronics, or it is not only the achievement of computer science or something. It is a collective achievement for many disciplines. Like just think that if we didn't have this touchscreen kind of concept, like this material science advancement, then probably smartphones would never been a reality, and probably we could never see such a world that we live now. On the other hand, that's obviously the biggest achievement from the material engineers in the smartphone industry. On the other hand, there is a very big contribution from the chemical engineers in terms of battery, chemical engineers and chemistry people, who came up with very novel ideas. Like first we had nickel metal hydride batteries, then we had lithium ion, and then lithium polymer. And those batteries were now storing a lot of charge. And these smartphone devices are ever power hungry, so you need more and more applications. You want this battery to go on and on. And then now we have the electrical people also. Like just think about this fast charging concept and so on. Like nowadays you can probably charge a mobile phone with a turbocharger within 30 minutes. So there are a lot of such developments coming from all the disciplines which are coming into this. And even if you think that there is no contribution of bio people or so, then you are also wrong. Like we have this biological based fingerprinting and other kind of technologies which are imbibed. Like you can have now a retina scan or a fingerprint scan or some face scan which are involved. So there is a lot of contribution from computer science as well as other traditional departments. So the device has come up a long way, and it's a collective effort for many disciplines. So these are the things which hindered the like adaptation of 1G. So I'm not going to talk more about 1G because 1G phones we never experienced probably in India, but there are some lessons to be learned. The first lesson was like this architecture, like architecture. By architecture we mean that mobile stations are connected to base stations are connected to the mobile switching center, something like this. So this kind of architecture is still very valid. Then the cellular concept, that you are dividing the whole region into cells and then each cell has a tower, that design is also very much valid. So these kind of basic ideas which appeared in 1980s are still very, very relevant today after 40 years or so. Now it's time to talk about 2G, and I will spend a bit more on 2G because 2G is what that shaped developing countries like India. And it would not be an exaggeration to say that with such 2G networks, there was a huge financial impact of China becoming a superpower as well. Like in these countries, the penetration of technology was very fast, and they remarkably changed the whole economic and the market sector, different market sectors. Well, the second generation was developed in 1990s, and if you ask that when the whole thing was coming, well, in 1993 the GSM standard was first coming to the market. In 1994 the CDMA standard came to the market, and it is very astonishing to see that in 1995 we had the first call in India. Well, the West Bengal chief minister made the first call from Calcutta to Delhi. It was via Modi Telstra phone, and that was the beginning. Like, what I mean to say is that India was nowhere lagging now. So the technology was being introduced in US, in Europe, in India, in Africa, in China, in Australia at the almost at the same rate. Earlier, we had very few people who had phones, but now people were demanding this kind of software phones, 2G phones. Well, at the initial days, the 2G phones were only the property of the rich people, because if you think that the first phone that came up in 1995, it cost around 45,000. The 45,000 is a huge amount even at today's standard. Now 45,000 in 1995, that's 27 years back. That's a huge amount. So obviously, very few people could afford that. And the call cost at that time was something like 16 rupees per minute. And even for receiving a call, it was like 8 rupees per minute. So it was a common practice. Like, if you are not probably willing to take somebody's call, you simply cut and probably go to a phone booth and then probably call that person. So those were the things in the earlier days. But soon it changed. Like, when a technology is introduced, initially the market is monopolistic and the prices are quite high. Then more and more people come to the market, more and more companies come, competitions begin, the prices begin to fall. And that's what started from 1995. By 2005, like within 10 years, the prices were so low that everybody could afford a mobile phone, and probably the call cost in India was the cheapest in the world, and so on. So I'll just talk a little bit about the technologies. Well, the first technology was like the 2G phones were digital. Now, there are some modulation and all these things I have written here, GMSK. You need not to understand all these things. What you need to understand is, once you convert something from analog to digital, then the game changes completely. Because you see, when you had an analog camera, for example, then that analog camera had a film roll, and you could never even think that an analog camera can play your sound as well. Like, you can put a cassette and you can play a cassette there with an analog camera. So a cassette player and an analog camera are two distinct things. So merging them together, nobody can even think of. But just think of a digital system where everything is in ones and zeros. So the same digital system can probably take a picture, can record your sound, can play back your sound, can store files, can do everything. So once you have a digital phone, then the possibility of doing many things automatically popped up. Like, once you have a digital phone, you can store something. Once you have a digital phone, you can write some text and send. That is the idea of message and SMS, that those things are coming. Then you can probably store pictures, you can probably send them, you can probably record voice and whatnot, and probably you can combine them. So you can have like multimedia message, MMS, where you can probably like include video, sound, everything with text and so on. So it's not that in 2G it all started readily, but the groundwork has been already established. So that's a big step, like going from analog to digital, which was another big step in 2G. The second big step was roaming. Well, the 2G standard was somehow pushed very hard by the consortium, and it was accepted worldwide. So it was now possible that we had a phone and we can roam to different countries, which was not earlier possible. Well, the driving force behind this was European Union, of course, because they had small countries. They were like having a Schengen area and they want to move freely among them. But they convinced Africa, and they also convinced much of Asia. So like this Asia, Africa, and Europe are enjoying something like a similar standard. On the other hand, the US standard was CDMA, and they convinced Latin America. So the North America and Latin America were in one group. So it was again a Cold War kind of situation at the time. Like we had two groups in the world. One was GSM group, one was CDMA group. And fortunately, India was again kind of neutral, and India was one of the very few countries who enjoyed both. We had GSM share and we had CDMA share as well. GSM was winning around having 75% share, but CDMA was not very small. It was also having 25% share. The only other country that could successfully do it was Australia. So anyway, so these were the idea of roaming and GSM and CDMA. And then we had something called SIM card, or subscriber identity module. Now, the SIM card concept was introduced for the first time in 2G. In 1G, there was no SIM card. So there was no separate business for the equipment manufacturer and the telecom operator. It was like if you buy a phone, you buy the SIM card along with it, or there is no existence of a separate SIM card. But with 2G, it was like you can buy a phone from Nokia, but you can buy a SIM card from Reliance, so, or Airtel. So this make the market segment divided into two domains, and the competitions were much more fair. So some companies were only focusing on device manufacturing, like Nokia and Sony, and there were like Samsung. On the other hand, there were some telecom operators like this Airtel and so on. They came up with the SIM card, and they were setting up the towers, and they were looking after the network infrastructure. So the whole market was divided into two domains, and it was good because it was possible to buy a phone from Finland and then insert a SIM card in India and then probably enjoy the local service. So such kind of global exchange were now possible. So these are the three big things, like the conversion to digital, the like the enabling of roaming, and then the SIM card. Now, I was talking about like GSM and these things, so I will just quickly go through them. Well, what happened was that in European Union we had this GSM standard. Then in US we had something like a copy of GSM, but that was not very successful. US came up with DAMPS initially. It was like US was not leading at the time. Like the Europe was already ready with GSM, and US was trying to have a digital version of the AMPS, which they had in 1G version, but people are not very much interested. And then suddenly this CDMA concept came, which was not a government or something. It was coming from a private kind of thing, and that was quite successful. And then US started, and the US started pushing the CDMA standard. On the other hand, in Japan, we had something like called Personal Digital Cellular, or PDC, which was mostly like GSM. So let us now talk a little bit about the 2G achievements. Now, when we consider 2G achievements, the major idea is that the mobile is now first time for the masses. So I'll just give you two statistics here, that in 1990, we had a global teledensity of 2%. So that means out of 100 people, only 2 people could afford telephone in 1990. And in 2000, it was 39. So there is 20 times increase. That means something like 2000%, right? Increase within just 10 years. And in India, and in other developed countries, it was a great migration because some people were having no phones and they were first time using a 2G phone. Now, that was a big market drive because in US, for example, some people already had bought 1G phone. They were very reluctant to give away that phone, that costly thing, and then buy another costly thing. But for India and other places where the 2G phones were first time being introduced, the penetration was kind of smooth because earlier they had no phones. Now they have suddenly access for the phone. And in India, earlier, the getting a connection of a landline was also very difficult. It was having very limited resources. So even if you had money, probably you had no resources for communicating. So it was a great leap. Then, as I was talking about new digital services, like once you have a digital platform, then you can get messaging, you can get data use. So although the 2G phones were not great for using data, you still had only very limited amount of connectivity, which started from 2.5G onwards. Of course, I'll just describe it now. But the platform was there. And the third point, that was separation of OEMs and service providers, which I was talking about. Like OEMs means original equipment manufacturers, like the phone manufacturers, which are like Samsung or Oppo or Vivo. Oppo and Vivo was obviously not that time. So that time it was Sony Ericsson and Nokia mostly. So that they had a different market, and service providers are like the telcos or telecom operators, which are like this Reliance, Airtel, Vodafone, BSNL, and so on. So that was another achievement. Now, I will quickly talk about 2G plus or 2.5G, and then I will leave the 3G thing for tomorrow. So let us talk a little bit about 2.5G, which came right after the 2G. Like when 2G things were successful, people were demanding more and more data through 2G. So they were having like packet switch kind of network, and people focused more on data rate. Like from 2.5G onwards, it was never the call was never a priority anymore. So it was cellular phone, but it was not used for as a phone. It was used for something like data transfer device. So now onward, like 2.5G onward, people always ask for what data rate your network can support. That's the major question. So we had something like GPRS, which came in I think in 1998 or something like that. And then in India, it came a bit late, 1999 or 2000. And I still remember that Edge was being advertised in 2003 or so. So it was again another version which is called enhanced data rate for GSM evolution. The data rate, you can see that it was increased up to 115 kbps and then 384 kbps. And on the US side, it was 153 kbps. It's not great speed, but still you can probably browse some pages. So what kind of 2G plus things we had? Well, we are still not ready with a smartphone. That's something like 3G offered. So, but with the old phones, we had some kind of internet-based services. What? Like downloading ringtones, like having horoscopes, like having cricket scores, and so this kind of things. So those kind of internet-based services were there. There were mini browser kind of things, like mobile, like they had XML pages and WML pages. So those WML pages, wireless markup language was conceived, and they were making the websites based on that. So some small websites probably could be accessed. And then advanced text services came, like you can now realize multimedia message service, like you can add a voice clip or you can add a small video clip with your message and you can send it. And 2.5G obviously fueled the development of smartphone. Like we thought that once we need to have this internet-based devices, then obviously we need a better device to take care of. Like if you remember the BlackBerry phones, they had a very large keypad that was something like QWERTY keypad. But this QWERTY keypad was like taking a lot of space in the mobile phone, and so it was not very handy. So it was like this much mobile phone, half of the part is eaten by keyboard, but the keys were very small, so it was very hard to push. So people were thinking of some other technology where we can have better typing and other kind of data input facilities. So the like the path to develop a smartphone was getting developed. So this is about 1G and 2G in nutshell. So I will just quickly recap the whole thing, and I will keep the 3G and 4G for the next class. And in the next class, which will be after the mid-sem week, we'll be talking about 5G. And then we'll move to the other things like WLAN, and then we'll go to the next module. So let me just quickly recap what we discussed today. Well, we discussed today the technologies of 1G and 2G. 1G was developed in 1980s, 2G developed in 1990s. 1G had little impact in India because it was only launched in some developed countries. But there were some lessons that we learned from 1G, like how to have a cellular structure, how can we have a base station, mobile station, and mobile switching center connected, and so on. And we had some other things like demand for licensing and so on. Those were felt. In 2G, the scenario changed because it was digital, so there were new services coming up. There was idea of roaming, there was idea of SIM card. So these were 2G achievements. And 2G paved the way to 2G plus, where people wanted more and more data out of their phone. In 2G plus, we had this multimedia message services, we had internet-based services, and we were starting to develop the smartphone as well. So here we end today's class. I will stop the recording now, and